Hello and welcome back to the lecture on applied econometrics. We have been talking about instrumental variable. In the previous lecture, we spoke in detail about the identification of the IV regressor and a two-stage least square. Now, in this lecture, we are going to detail this two-stage least square and how we use this technique for regression using IV estimator. Now, let's distinguish these two terms. So, when we say two-stage least square and IV regression, they are basically same, but two-stage least square is something that we say when we have an over-identification strategy. So in case of over-identification, where we have, let's say, two uh, our instrumental variable, they are actually determining x variable or endogenous variable. So then in that case, let's say x is equal to h1 plus h2 z2 h3 z3, and let's say I have some error term. Then in that case I the strategy that I use, the OLS strategy that I use, that is basically, or we call it a 2SLS. Okay, now here the Z2 Z3, they all have to have all these properties of IV satisfied. Whereas for exact identification, when I have my number of endogenous variable is equal to my number of instruments, so then we call it a case of IV. Okay, but the strategy remains same. Okay, the strategy remains same in the sense that we have this first stage, we do the OLS estimation, and in the second stage, we use this estimation to do the uh, actual regression equation. So here we can write something like maybe delta 1, delta 2, let's say, or delta 3 Z3, and some error term, some, let's say, mu. So in this case, this is an IV, whereas in over identification we call it 2SLS. But they're basically same, and we can just say that 2SLS might have a larger ambit, whereas IV is a part of this 2SLS strategy. Okay, IV, and the outer part is basically 2SLS. All right. Now, let us write it mathematically, how it will look like. So let's say, if we do the first stage least square, so let us think about our example of wedge rate. So wedge rate W is equal to, we have written alpha 1 plus alpha 2, and then we had our P, and then we had alpha 3, and then unemployment, and then we had some error term. Okay. Now, here for IV, in the first stage, what I'm going to do, I'm just going to use U as my Z. So I will have my W, I'll be writing this equation. So let's say some row 1 plus row 2 U and some other error term. Let's say new, I'll be repeating all these error terms. And here I what I do is I actually get a W estimated. Okay, so when I estimate W, so I get a row 1 hat, row 2 hat, and U, right? So I actually estimate these coefficients, row 2, row 1 hat, and row 2 hat. Now when I get these values, what I do is I actually use this in my original equation, and that is a price equation. I'm basically estimating price. So let's write down the structural equation for price here. Price is equal to, I had beta 1 plus beta 2 W plus UP. Now here I am supposed to replace W. So let us number the equations also. 2, 3, and this is a 4. Now I will use equation 4, W hat, and replace the W here. Okay. So what I'm going to do, so now my P is going to be, let's say, some 0, 1 W hat, and then I have some other error. Let's say error mu prime. Now I'm simply using this value from this equation to equation 1. So this is going to be my equation 5. And this is where I'm claiming that I have actually solved the endogeneity problem. So this W hat is no longer having this relationship with UP. So it is no longer covariant with the error term. Now, How exactly I can claim that? To illustrate that, let me actually take help of a diagram. So let's actually try to see all our different components of our regression. So let's say we have our y. Let's say y is here, x is here, and my error term is here. Okay. Here my y is p price rate, price rate. Here is wage rate, and this is my UPI. Okay. Now I want to see the impact of wage rate on the price rate. So this is something I am really interested in, and I know this error term is actually influencing the y, and that is fine. But which I don't want is that a channel here. This is something I do not want, so I mark it as red. Now, basically, if I have a channel here, what will happen? A part of x influence will go through u, and that will again influence y. So the coefficient I will get for x is going to be distorted. So I don't want that, right? So in order to avoid this, what I'm going to do, I'm basically claiming that, let's say if I can have a z here, and if that z can help me to estimate a x hat, so what I can do is I can actually basically create, or I can have a variable, not a variable which will not be related with u. Okay, so let me actually write it down. So let's say this is my z, this is my x hat. So x hat is nothing but my wi hat, and z is nothing but ui. And here let's say some other error term we have. Let's maintain the consistency of color. So let's say this is let's say this is some theta is the error here. Now what I'm claiming is that this z and this error is actually helping me to estimate my x hat. Okay, and x hat is nothing but my wi hat. So this, instead of using w, I'm using wi hat to predict my price. So that's what I exactly did previously. So I'm basically creating this, and I'm saying that now since I have x hat, so this relationship is no longer there. This relationship is no longer existing. Now, how I can claim that this relationship is no longer existing? Okay, so if I have x hat, so does that mean I have freed my equation from the error? Well, so we can think it in terms of the very simple regression that we have done at the beginning. Okay, so where we had simply plotted in two-dimensional graph x and y, right? So we had x and we had y, and then we plotted all these points here and there. All right, and these are my y actuals, so yi's, and then I had my regression line. Okay, I had my regression line, which this regression line is basically representing all these yi hats, right? Now this yi hat, I got this yi hat only after removing the error part, right? So yi minus the error is basically the yi hat, all right? So when I remove the error, I basically, when I get my wi hat, so it is an estimate of wi, so I can claim that then no longer it is related with UPI. So basically that is how we can claim that it is free of the error term. And then when I take the regression using x hat, so we basically solve the endogeneity problem. So that's basically the intuitive understanding behind how we can use the estimated endogenous variable. Okay. Now, if it is a case of over-identification, we can use the same strategy. So, for example, in our previous case, W was related to, let's say, both money supply rate as well as unemployment rate. So what we can do is we can, instead of one instrumental variable, I can have, let's say, H1 plus H2 U and H3 M and some U prime. Now, when I basically do it, I basically regress it. So by regressing, I get W hat, which is H1 hat, H2 hat, U, plus H3 hat M. Okay, so this is something is a case of over identification, so we call it 2SLS, but the strategy remains same. This to an instrumental variable, I get my W hat and I substitute my W hat into my structural equation. Okay, structural equation of price. So that exactly what we have done previously. All right. So this is how we do this. This is how we use 2SLS to solve the IV regression case. Now in Stata, how we do it? We usually the command is like this. We will do the hands-on in the next class, but the command is something like this. I wanted to introduce the command just to have a sense of how we actually do that. And we will see that in the first stage, in this most of the softwares, we actually don't do the first stage separately. So let me write down the command. So we basically write IV regress to SLS. Then I write the Y variable. So here let's say price rate. And then I write the X variable, my endogenous variable, which is wage rate. And then I write the IV that I want to sort of assign for this wage rate. So let's say unemployment rate, U rate, let's say I'm writing. And then I didn't have any other X variable, so it's fine. But if I, let's say, if I want to have two IV, okay, so I can write IV regress to SLS, the same price rate, but in the bracket, I write wage rate is equal to, let's say, U rate, and M rate. Okay, so two IV I can just assign like this. Now let's say in my price equation there was another explanatory variable. Let's say that was, let's say, oil price. So price rate can actually vary with oil price. So if the oil price is increasing, my prices of other goods usually increase in the economy, right? So if that is the case, so then I can write my IV the regression I can do is like this: price rate, wage rate is equal to U rate, M rate, and then I can close the bracket. Reduce the size a little bit. I can close the bracket and then I can write, let's say, oil price. So this is how we do the regression, IV regression in Stata. Okay. Okay. Now some mathematical properties. So one thing is that usually you may see the variance or standard error for the IV regressor might be actually more than the OLS, and that is because it depends the standard error. Since the IV regressor, you are not actually using the original X variable, original regressor, but you are using some estimate of that. So that is actually going to be less precise, and the standard error is going to be high. Okay, so there is nothing to worry about on this. The second part is when we do the first stage regression. So I said in software you usually don't it usually don't give you the result for the first stage regression. So what you do, you basically run the first stage regression separately, and you see if the properties are satisfied. So usually what properties you see? A very good R square value. Then secondly, you see if the residual sum of square is low, and third, you want the correlation coefficient or the covariance between X and Z to be a good one. Okay, it has to be good correlation coefficient. Now, how do we represent the beta to let's say IV in this case? It is going to be, or beta to 2SLS, we can also write 2SLS. So 2SLS is the general case, right? For both, it basically encompasses IVs also. So how I'm going to write, so usually the usual equation is Zi minus Z bar into Yi minus Y bar divided by Zi minus Z bar into Xi minus X bar, right? So in the previous case, if I think about our wage rate and price rate equation, so how it is going to look like, let me change the color a little bit. So it is going to look like, so instead of Zi, I'm going to have my Wi estimated, right? And then that estimated bar, right? Into, I have my Pi, Yi is here my price rate, Pi bar, P bar. That's the numerator, and in the denominator, what I'm going to have? So my xi is wi here. So I'll write wi minus wi. This is for x. And for z, I'm going to write wi estimated minus w, right? So this is what the beta 2 SLS is going to look like. All right. And here again, if suppose we are actually, having an overestimation case where I have more than one IVs, so usually the standard error is going to be less if I have an exact identification. And the reason is when I have more than one IV, I'm going to have my first stage least square, first stage regression going to be more accurate. Okay. So that is why my error is going to be a little less. All right. So one last thing, so there are some other ways actually we also do this IV regression, and you remember that we estimated world estimate in the first example we have given, and this is I'm going to show you how we actually calculate that. So here what we do is, let me write down the equations again. Let me write down Pi is equal to beta 1 plus beta 2 Wi plus UPI, whereas my Wi is equal to alpha 1 plus alpha 2 into my Pi plus alpha 3 into U, and then finally there is an error component, UWI, let's say, okay? Now in this case, what we do is, let's say we have our, in the first stage regression, I will have Wi is equal to H1 plus H2 UI, okay, UI, and let's say some error term. And when I estimate it, I get Wi hat is equal to W hat is equal to H1 hat plus H2 hat into U. Okay. Now, so that is how we used to do previously. That is how we have learned we do, and then we substitute W hat into the first equation. Okay. Again, I number the equations 1, 2, 3, 4. Okay. Now, in this case, we'll do things a little differently. So what I'm going to do, instead of actually substituting W into the first equation, what I'm going to do, I'm going to use the IV, the U, directly into the first equation. So what I mean by that, so let's see, Pi is going to be, let's say I use theta now, theta 1 plus theta 2 U instead of UI, so Pi UI, so instead of Wi, I'm going to use UI, okay, and let's say some, I don't know, let's say some error term is some mu prime, let's say. So this is what I'm going to do here. Instead of using the W estimated, I'm going to use the instrument directly into the second stage regression. Okay, so this is my equation 5. Now what I get, so my H2 hat and my theta 2, what do they really represent? So here what I'm doing is, I'm actually estimating my Pi, okay? So I get, let's say, P hat. If I estimate P hat, so it is going to be theta 1 hat plus theta 2 hat into U, right? So my error term is gone. So let's say this is equation 6. So this is a fitted equation. So now look at the equation 6 and my equation 4, okay? So in equation 4, I have estimated my endogenous variable W, and in equation 6, I have estimated the dependent variable that I wanted to understand, the relationship with the independent variables. So this is the price rate. So essentially, what this H2 hat and theta 2 hat says. So H2 hat says basically change in unemployment rate and its impact on the wage rate. Okay. So basically, I can write delta wage by delta unemployment. Whereas my theta 2 hat is saying change in the price rate with the change in the unemployment rate. Okay. Now, what world estimate said? World estimate, we took the coefficient of the reduced form equation, which is basically this one, the main equation here. So basically delta P by delta U, and then we divided it by the first stage regression. So basically delta H hat, so which is H2 hat, which is delta W by delta U. So if I simplify it, it is going to be delta P by delta W. So essentially it means I am looking at the change in the price rate with change in the wage rate. So that is basically what I wanted to get in my equation 1, right? So with world estimate, exactly that is what it is giving us. So it is basically telling the delta change in Y with respect to delta change in the explanatory variable. But unfortunately, since the explanatory variable had endogeneity problems, we had to basically follow through all these different routes. Okay, so this is how we do it. And with this, we will end this lecture here. And in the next lecture, we are going to do some hands-on using this data. Thank you.